For nearly a century, humanity lived under a comfortable cosmic illusion. We looked to the outermost rim of our solar system and saw Pluto as a mere postscript, a frozen pebble, a lonely afterthought, drifting through a perpetual graveyard of ice. It was so small, so impossibly distant, that our greatest telescopes could resolve it only as a pixelated smudge against the black canvas of infinity. In 2006, we stripped it of its planetary title, rewriting fifth-grade textbooks and solidifying its status as a dead, inert relic of the ancient solar system. It became the only world in human history to be discovered, celebrated, classified, and then officially demoted by a committee vote. But cosmic truths do not yield to human classifications. In the winter of 2022, the James Webb Space Telescope turned its massive, gold-plated hexagonal eye toward that distant pinprick of light. Webb does not take snapshots. It takes chemical fingerprints. It peers into the infrared spectrum, capturing the unseen heat and molecular signatures of the cosmos. What its mirrors reflected back didn't just surprise the astronomical community. It shattered our fundamental models of planetary science. Webb revealed a world that is actively defying thermodynamics, a world executing complex prebiotic chemistry in real time, and a world locked in a chilling, vampiric relationship with its largest moon. This is the untold story of what Webb found out there in the dark, and why it proves that the edge of our solar system is not a barren wasteland, but a dynamic, unsettling frontier. To truly comprehend what Webb discovered, we must first understand the baseline established by NASA's New Horizons flyby in 2015. Screaming past Pluto at over 30,000 miles per hour, New Horizons revealed a stunning blue atmospheric haze wrapping around the dwarf planet. But a mystery lingered in that atmosphere, one that traditional physics struggled to explain. In planetary science, atmospheric hazes are generally expected to act like a blanket. On Saturn's giant moon, Titan, the thick hydrocarbon haze absorbs incoming solar radiation and warms the surrounding atmosphere. For years, scientists assumed Pluto's atmosphere operated on the same principle. Enter the James Webb Space Telescope. Utilizing its mid-infrared instrument, MIRI, an international team of astronomers set out to map the exact thermal structure of Pluto's thin sky. What they found turned the physics of planetary atmospheres upside down. Pluto's haze is not warming the planet, it is actively chilling it. The complex hydrocarbon particles suspended in Pluto's atmosphere act like microscopic interstellar radiators. They absorb the faint, diluted trickle of sunlight reaching the outer solar system. But instead of trapping that energy, they violently radiate it away in the mid-infrared spectrum. They are literally bleeding heat out into the vacuum of space faster than the sun can replace it. The implication is staggering. Pluto possesses a self-cooling mechanism unlike any other atmosphere in the known solar system. It is a world that actively drives its own temperature down, maintaining an atmospheric state that is vastly colder than our standard thermodynamic models ever predicted. We are looking at a planetary refrigerator operating on a global scale, and our current computer models don't even know how to fully simulate what happens next. If the temperature of Pluto is unsettling, The chemistry occurring within that cold abyss is downright haunting. Even at a distance of nearly 4 billion miles, ultraviolet photons from the sun strike the methane molecules in Pluto's upper atmosphere. This faint solar bombardment is just strong enough to break the methane apart. The broken molecular fragments then recombine, building increasingly complex and heavy compounds: ethane, acetylene, ethylene, and a vast zoo of complex hydrocarbons. As these compounds grow heavier, they clump together, forming macroscopic, reddish-brown organic polymers known as tholins. Webb's ultra-precise spectroscopy resolved these tholins at an unprecedented level of granularity. For 4 billion years, Pluto's sky has been dropping a slow, silent, uninterrupted snowfall of organic chemistry. This is not water snow. It is a rain of prebiotic material coating the landscape in a thick shroud of frozen organic matter. Tholins are the exact same class of complex organic molecules that scientists believe rained out of Earth's primordial atmosphere billions of years ago, collecting in our ancient oceans to form the chemical soup from which life eventually emerged. On Pluto, the raw ingredients of biology are falling from the sky every single day. Yet, they land on a world so fundamentally frozen that they are trapped in a state of permanent arrest. It is the chemistry of life, frozen mid-step, preserved in a cosmic freezer where time itself seems to stand still. At these temperatures, hovering around minus 380 degrees Fahrenheit, the physics of familiar materials completely warp. The nitrogen that makes up 78% of the air you are breathing right now freezes into soft, shifting glaciers. Methane becomes structural ice. Carbon monoxide falls as crystalline frost. The very gases of our atmosphere are transformed into the solid bedrock of Pluto's alien geography. Perhaps the most eerie revelation confirmed by Webb in recent years is that Pluto is actively leaking. Because of its weak gravitational pull, Pluto cannot hold on to its entire atmosphere. Every second of every day, methane and nitrogen molecules drift away from the dwarf planet, escaping into the cosmic void. But this lost material isn't just scattering into the emptiness of the Kuiper Belt. Something is catching it. Pluto's companion moon, Charon, is a battered world of pure water ice, roughly half the size of Pluto itself. The two bodies are so close in mass that they do not have a traditional planet-satellite relationship. They are tidally locked, facing one another permanently, orbiting a point of empty space between them. They are locked in a cosmic waltz, spinning like a double-headed dumbbell. For decades, scientists stared at New Horizons images of Charon's North Pole, which features a bizarre dark red stain, informally named Mordor Macula. They had a hunch about its origin, but it wasn't until Webb's data was analyzed that the terrifying reality was verified. Charon's red pole is painted with Pluto's stolen breath. As Pluto bleeds its atmosphere into space, Charon sweeps through the debris cloud across the 12,000-mile abyss separating the two worlds. Charon's gravity siphons the escaping methane molecules. During the brutal cold of Charon's winter night, this stolen gas freezes directly onto its poles. When spring arrives and the first rays of sunlight strike the frozen methane, cosmic radiation cracks the molecules apart, synthesizing tholins right on Charon's face. No other system in the solar system exhibits this behavior. It is a slow, silent, vampiric exchange. One world is bleeding its atmosphere into the void, while its sister world catches the remains, dyeing its own polar caps with the leftovers of its partner's decay. Furthermore, a landmark study led by Sylvia Protopapa using Webb data confirmed the presence of frozen carbon dioxide and hydrogen peroxide across Charon's wider surface. The Moon's ice is being continuously bombarded by galactic cosmic rays, rearranging basic water molecules into a toxic, bleached crust of peroxide. A bleeding planet feeding a poisoned moon. This is the true landscape of the outer solar system. If you were to descend through the self-cooling haze and stand upon Pluto's surface, the geography would look like something out of a fever dream. To the east of Pluto's famous nitrogen ice heart lies a region called Tartarus Dorsa. Here, the landscape is guarded by an endless labyrinth of ice spikes, known as penitentes. These are jagged, towering blades made of solid, frozen methane, rising up to 1,500 feet into the thin sky. Lined up in parallel ridges, like a vanguard of cosmic knives, they dwarf any similar structure found on Earth's high-altitude deserts by orders of magnitude. Webb's recent spectroscopic surveys suggest these blade belts may gird up to 60% of Pluto's equator, a literal ring of frozen blades cutting across the world. Yet it is what lies to the south that completely upends our understanding of planetary geology. Rising out of the plains are two colossal mountains, Right Mons and Picard Mons. Picard Mons stands nearly 20,000 feet tall, its footprint rivaling Mauna Loa, the largest active volcano on Earth. At their summits lie deep, cavernous depressions ringed with fractured, lumpy terrain. But these are not traditional volcanoes. They do not spew molten rock. They are cryovolcanoes. Instead of magma, these gargantuan engines have erupted a thick, slushy slurry of water ice, ammonia, and methane from deep within the planet's interior. The smooth, uncratered surfaces surrounding these peaks indicate that this activity happened in the incredibly recent geological past. Think about the implications. Pluto is not a dead, frozen rock. It possesses an internal heat engine. Billions of years after its formation, a world the size of our moon still retains enough internal warmth to melt ice, pressurize liquids, and reshape its surface with titanic cryovolcanic eruptions. The presence of cryovolcanism points directly to the ultimate, most controversial hypothesis in modern outer solar system science, the existence of a subsurface ocean. The math, bolstered by Webb's precise gravitational and compositional models, is increasingly clear. Beneath a 100-mile thick shell of water ice so cold it behaves like granite and rings like steel when struck, Pluto is likely hiding a global liquid ocean. This ocean is kept liquid not by sunlight, but by the slow, steady decay of radioactive elements within Pluto's rocky core, insulated by the thick crust above. The massive impact basin of Sputnik Planitia exhibits a positive gravity anomaly, a concentrated mass beneath the surface that can best be explained by a dense layer of liquid water welling up from beneath. If this ocean exists, it has endured for billions of years. It is pitch black, highly saline, under immense pressure, and enriched with ammonia. And it instantly transforms Pluto into one of the most compelling places in the entire universe to look for extraterrestrial life. We often look for life near stars, inside the warm Goldilocks zones of planets like Earth or Mars. But Pluto suggests an entirely different paradigm for habitability. It represents a class of worlds where life could theoretically thrive, completely independent of a star's warmth, sealed inside an acoustic thermal tomb of ice, fed by organic hydrocarbons filtering down through cracks in the crust, sustained entirely by the dying embers of a planet's internal radioisotope heat. The ultimate revelation of the James Webb Space Telescope is not just about Pluto itself, it is about what Pluto represents. Pluto is not an anomaly. It is the gatekeeper to the Kuiper Belt, a colossal donut-shaped ring of icy debris harboring hundreds of thousands of objects larger than 60 miles across and an estimated trillion comets. Beyond that lies the Oort cloud, stretching a quarter of the way to the nearest star system. Before Webb, we thought of this outer realm as an empty, frozen wasteland. Webb has permanently dismantled that assumption. If Pluto is executing active thermodynamics, running complex organic chemistry experiments, leaking its atmosphere to reshape its moons, and harboring a liquid ocean, then thousands of other worlds out there are likely doing the exact same thing. Worlds like Eris, Makemake, and Haumea, along with countless unnamed bodies drifting through the perpetual night, may all be hosting their own silent, multi-billion-year chemical symphonies. They are running the software of life in real time, completely unobserved. Pluto is not a planet, nor is it a mere postscript at the back of a science textbook. It is a profound cosmic warning. It stands as definitive proof that the universe is far busier, far more dynamic, and far more alive in the dark than our primitive imaginations ever dared to dream. And we have only just begun to look.